Hi, my name is Matthias, and I would like to introduce you to PETS, a newly developed perceived empathy of technology scale, which makes it possible to measure the empathy of systems toward the user. Empathy is an important concept in social interaction. And while there are different views and ongoing discussions about empathy and its related concepts, most definitions agree that there is a cognitive and an affective component. Cognitive empathy refers to the perception and understanding of another person's feelings, for example, based on the interpretation of context and facial expressions. Affective empathy can be understood as an emotional reaction to this perception. Now, with the advances in affective computing, also systems and applications are able to perceive, understand, and react to our emotional expressions. But if a system responds to our emotions, like here in the example, how do we know if it is perceived as empathic? To measure empathic human behavior, there are already established scales. However, there aren't any established and especially no validated scales for measuring empathic system behavior. Therefore, we created PETS as a validated scale specifically developed to let users rate empathic system behavior after interaction. For that, we followed a standardized multiple-step process for scale generation, involving item generation and validation from expert input, item testing and reduction through exploratory factor analysis, and scale evaluation. In this process, we initially developed 100 scale items, which in the end were reduced to a 10-item, 2-factor scale. For the initial generation of items, we opted for a bottom-up approach, as we assumed that empathy, when perceived by a system, does not necessarily follow the same mental model, the same definitions, as in human interaction. So in the first step, we interviewed 18 experts from various relevant fields like psychology, HCI, social theories, and scale development, and we asked them about empathy in human interaction and about empathic systems. Finally, we transcribed and coded the interviews in a semantic analysis process, which resulted in 100 initial scale items. Some of them clearly describing cognitive and affective dimensions, like the system recognized my nonverbal cues or the system expressed emotions, but also other items, for example, related to communication style, like the system actively engaged. All items are listed in our paper. In the next step, we invited a new group of 8 experts, which we asked to rate each of the 100 items regarding its relevance for our scale. Based on the rating results, we reduced the item set and conducted a focus group with 6 experts. In this group, we discussed and revised the remaining items to a set of 38 items. With this item set, we proceeded to the next phase, item testing and reduction. For that, we created 18 test scenarios, each describing an interaction between a user and an empathic or a non-empathic system. The systems differed in terms of embodiment, emotional expressions, degree of proactive support, and cognitive understanding. We then conducted an online user study with 324 participants recruited via Prolific. The task was for each participant to read and to listen to a randomly selected scenario and then rate how they perceived the system using the 38 scale items we created. With the study results, we conducted an exploratory factor analysis, which revealed a 2-factor structure with 12 items, with excellent internal consistency and acceptable values for TLI and RMSEA. Now, the next step was to verify and evaluate this 2-factor structure. For this scale evaluation, we used 4 new scenarios, This time not only as audio and text, but as visual animated sequences. We created 2 scenarios with empathic systems and 2 with non-empathic counterparts. A non-empathic game training app, an empathic robot-like game companion, a task-oriented office application, and an empathic work companion. Each of these video sequences lasted between 1.5 and 2 minutes. Using these scenarios, we again conducted 2 user studies via Prolific. This time, participants had to watch a video and rate the perceived system behavior on our 2-factor scale. After a first run with 200 participants, we conducted confirmatory factor analysis, which, however, revealed a slightly too high RMSEA. So we looked at the modification indices and removed 2 of the 12 items that appeared to be the reason for the non-optimal fit. With this new 2-factor 10-item scale, we conducted another study with a new batch of 100 participants. For this structure, the results revealed an optimal fit. So we got the final 10 PETS items and a scale structure consisting of 2 co-varying factors, which, based on their items, we called emotional responsiveness and understanding and trust. As in our user studies, these items are designed to be rated on 101-point sliders, ranging from strongly disagree to strongly agree. To ensure that PETS results are consistent over time, we repeated the previous study after 12 weeks with 51 of the 100 participants of the original sample. Intra-class correlations and Pearson correlation indicated a high test-retest reliability for the total scale and good results for both subscales. And finally, we conducted a study with 96 new participants to ensure construct validity. This time, participants not only had to rate a test scenario with PETS, but also with 6 other scales. To make sure PETS is discriminable from other constructs, we compared established scales for trust, anthropomorphism, and general usability. For all scales, we found PETS to have correlations, but to be sufficiently independent, which indicates that PETS is measuring a discriminant construct. To check convergent validity regarding cognitive and affective behavior, we further let participants rate 3 subscales of the networked mind's measure of social presence. We found PETS to have strong correlation with all 3 concepts: perceived affective understanding, message understanding, and emotional interdependence. The individual correlation values highlight the affective dimension of the first PETS factor, emotional responsiveness, while they show that message understanding as part of a cognitive dimension is nearly equally reflected in both PETS factors. Based on this validation and our bottom-up item generation, we conclude that the PETS items reflect the established cognitive and affective empathy dimensions. However, we do not see the 2 PETS factors as an exact division into these dimensions. You can find more detailed information in our paper and on our website perceivedempathyofTechnologyScale.com. And of course, feel free to apply PETS to test your systems. PETS is available under the Creative Commons license.